Like in the short run, if you remember the previous class with the short run production function, we had a different behavior. I hope you remember my example, photocopy machine and the number of workers. In the beginning, it was increasing at the increasing rate and then increasing at a decreasing rate and then decrease. The reason behind that was law of variable proportion. Law of variable proportion. I hope you remember. Likewise, the behavior of the isocont, like this, 100, 250, 400, something like this. That depends on something called returns to scale. In the long run, what we do, we scale up. Scale up means you are expanding your business. Since you are increasing all your production factors, in our case, capital and labor, we are increasing both capital and labor. When we increase both capital and labor, our firm gets expanded, right? So we say scaling up. Therefore, when you scale up your firm, what is happening to your output? This is given by the returns to scale. So in the long run, behavior of the production function will be governed by law of this returns to scale. There are three types of returns to scale, which we call constant returns to scale, increasing returns to scale, and decreasing returns to scale. In the constant returns to scale, we expect that when we increase our inputs, both inputs, by 100%, our output also will be increased by 100%. It may not be exactly 100%, but closer to that figure. So we say, when we double our input, our output also will be doubled. When we double our input, our outputs also will be doubled. Then we say constant returns to scale. I will show you with the graph, then it would be much clearer. Then the increasing returns to scale, that says when we increase our input by 100%, when we increase our input by 100%, our output will be more than 100. Our output will be increased more than 100%. When we double our input, our output will be more than double. Then we call it as increasing returns to scale. So when we expand the scale, our output will be increasing more than what we increase in our inputs. On the other hand, decreasing returns to scale tells us when we double our input, our output will be increased not by 100%, less than that. If we increase our input by 10%, our output will be increased less than 10%. So always output will be increased less than the increase in input. So we have these three types: constant returns to scale, increasing returns to scale, and decreasing returns to scale. Now here I'm having a very simple example. So let's assume we have isocont. This is isocont 100. And so to get 100 output level, I am mixing 50 capital and 200 labor. And this is my expansion path. I am having my expansion path like this. So this is my expansion path. So I'm going to increase my production along the expansion path. In the first case, I mix 50 capital, 200 labor. My output is 100. 50 capital and 200 labor, output is 100. Now what I will do, I will increase capital by 50%, 100%. 50 capital will be doubled to 100. So 200 labor will be doubled to 400. So both capital and labor increase by 100%. Then let's look at on which isocont we are going to stay. So we will be staying in isocont like here, which says 175. Right. So previously it was 100. So difference is 75. So it is 75%. Right. When we increase, when we double our input, both inputs, our output is less than double. We can check the next one. We will increase capital by 50%, 100 to 150. Labor also by 50%, 400 to 600. What has happened to our output? It is 225. So it is increased only by 50, which is much more less than the previous. So what happened? When we increase both our inputs, our output will be increased less than the proportionate increase in inputs. Then we call this as decreasing returns to scale or diminishing returns to scale. Why we call it as decreasing returns to scale? When you scale up, your output will be increased less than the input. So then we call decreasing returns to scale. The same way, in this example, we had 50 original condition, 200, our output was 100. Then we double both inputs, 50 to 100, 200 to 400. And our output is 250, which is increased by 150, more than 100%. If you go further ahead, increase capital by 50% here, 50% here, but your output is 600, more than 350. So whenever you expand your scale, your output will be increased more than the proportionate increase in your input. Then we call increasing returns to scale. And finally, same way we increase 100%, output also increase by 100%. It is 100, now it is 200. Increase your inputs by 50%, your output will be 300, increase by 50%. Then we call that as constant returns to scale. So when you increase your scale, your output will be increased the same rate at which you change your input. Right, depending on the type of the returns to scale, we will be having the level of output, which will directly affect on the cost. And in the long run production functions, we have the cost. Maybe next week we are going to discuss. So there we find that depending on this returns to scale, our cost structure also will be different. But I will be doing that in next day. So before that, we need to calculate the returns to scale in the Cobb-Douglas production function, which we will be using. In fact, we used. This one is a Cobb-Douglas type of a production function, this one. And this one also Cobb-Douglas. This one not. So this is known as Cobb-Douglas production function, this one, because we say it's something like Q is a function of capital and labor. Therefore, Cobb-Douglas type of a production function will have something like this, the generic form. A times K alpha L beta. A means the efficiency parameter, how efficient our production process. We did that. Ne? So this is efficiency parameter, and alpha and beta, these are known as allocative parameters. Allocative, how you are going to allocate capital and labor. Right? That is the functional shape of the Cobb-Douglas type of a production function. So now what we can do, we can use this Cobb-Douglas type of a production function and calculate the returns to scale. We can do that. Let's start with the generic form. This is the Cobb-Douglas type of a production function, AK alpha L beta. Now what we are going to do, let's change both capital and labor with the same proportion. That proportion, let's say this is T. It may be 10%, 50%, 100%, whatever it is. Let's say we will increase capital by T proportion. So we increase labor also with the same proportion. So both capital and labor are increased with the same proportion. Then we can solve it. Right, this is the original production function Q, and this is the production function after we increase it with the T proportion. Therefore, I put QT. We can solve it like putting T alpha. We are taking this alpha here. alpha, K alpha, T beta, L beta. Then we can take this common factor T, that is T alpha plus beta. The reminder is A K alpha L beta. This part we already know, that is here. So instead of that, we can put Q. Right? Qt star, that is the new output level, equal to T alpha plus beta times Q. So this is the output, original output level. So now, with this calculation, what you can see, what happens with the alpha and beta values? If alpha and beta equal to 1, so let's say this is 0.5, 0.5, this is 0.5. So T will be 1. Therefore, when you increase your input with T, your output also will be increased with T, because this is T times Q. Final answer. This one, because this will be T, this will be T. Therefore, that is T times Q. Right? Output will be increased with the T proportion. So we say alpha plus beta equal to 1, we are getting constant returns to scale. If it is a Cobb-Douglas type of a production function, easily we can say that alpha plus beta equal to 1, then we are getting constant returns to scale. Your output will be increased with the same proportion. If we are getting alpha plus beta more than 1, this may be 0.6, this may be 0.7. So we are having 1.3. So T power to 1.3. T power to 0.3, 1.3 multiplied by Q. Output will be increased more than the input. It is not with 100%, it is 1.3, 130%. Right? Therefore, when alpha plus beta greater than 1, we say we are getting increasing returns to scale. Finally, if alpha plus beta less than 1, we say decreasing returns to scale. So if it is a Cobb-Douglas type of a production function, it is very easy to get the returns to scale. And so let me take you to one example we had in the very beginning of this class. This one. Can someone say what is the alpha plus beta value here and returns to scale based on that? What is the returns to scale in this production function? You can look at the production table or the equation. Both are generating the same answer. Constant returns to scale. Exactly. Because alpha plus beta equal to 1. Here 0.5, here 0.5. So we are having 1. Right? So we are getting constant returns to scale if you do this with algebra. If you look at the table, you see here, we had 1 capital, 1 labor, 1 capital. Output was 200. Then we increased by 100%. 2 capital, sorry, 2 labor and 2 capital. Output increased to 400, 100% increment. And then we increase input by 50%, 3 to 4. And 2 to 3. And here also 2 to 3, 50%. Then what has happened to output? That is also increased by 200. And that is 50%. So this diagonal numbers shows clearly that when we expand our firm, when we increase our scale, whenever we mix capital and labor, output will be also increased with the same proportion. So we are having constant returns to scale. I think all the calculations we did with the constant returns to scale by purpose, but there can be different values. For example, let's say I will put here Q equal to 2. Now what is the returns to scale in this function? Q is a function of capital and labor. functional form will be 2k power to 0.4, L power to 0.8. What is the returns to scale of this production function? Is it constant, increasing, or decreasing? It is increasing returns to scale. At home, when you have free time, you can have the production table. Put different K and L values. You put K here, K 1, 2, 3, 4, 5, 6, like here. 1, 2, 3, 4, like there. Get the computer Excel sheet, put 1, 2, 3, 4, and calculate the values like this. And look at the diagonal. It says 100% increment, 50% increment, 25% increment, and so on, like this. Then look at the figures. What is happening? The numbers will be increased more than the increase in output. So we are having increase in returns to scale. On the other hand, numerically, we can do it easily. You don't want to draw the graph. You can just say 0.4 plus 0.8, which will be equal to 1.2. If it is more than 1, we are having increasing returns to scale. Therefore, this function will be having increasing returns to scale. Okay, so with that, I would like to finish for today.